Okay, this is the final exam from the fall 2018 semester of MA 161. Let's get started. Question 1, suppose the domain of f of x is from 0 to infinity inclusive. That's what the bracket means right there. It means it's saying you can plug in 0 for x. That's okay. If g of x equals 1 minus f of x plus 1, then what is the domain of the function g? All right, this is different than the typical domain problem. We're not really given any specific function, or at least we're not given f of x, but we know what its domain is. But we do a couple things on top of that, and it might shift our domain a little bit. So in order to figure that out, first what we can automatically exclude and forget about is this 1 minus here. Since f of x is the only domain that we have to worry about, anything else that we do on the outside of it isn't going to change that domain. So we're just going to scribble out the 1 minus, just worry about the x plus 1 in the middle there. Now, if you think about what happens here, when you add 1 to the x on the inside, that's obviously it's going to increase it by 1. But what that means for its domain is that, say you plug in a negative 1 for that. Now, the original domain says that's disallowed because negative 1 is outside of the domain. It's less than 0. But when we go ahead and factor in this plus 1, that's going to change it to 0. That's going to make it fit that endpoint perfectly. So our new domain should be from negative 1 to infinity. So answer choice C. Question 2, if f of x equals x plus 5 over x plus 1, simplify the expression f of x minus f of 3 all over x minus 3. Cool, this is just plugging in and simplifying. So f of x is just f of x, so x plus 5 over x plus 1, minus f of 3, which is 3 plus 5 over 3 plus 1, all over x minus 3. So simplifying first, let's probably do this. 3 plus 5 is 8. 3 plus 1 is 4. 8 divided by 4 is 2. So x plus 5 over x plus 1 minus 2, not plus, all over x minus 3. What we can probably do now is fracture this off into two different fractions that are being subtracted. So this will be x plus 5 over x plus 1 all over x minus 3 minus 2 over x minus 3. On the left side here, we can move that x minus 3 into the denominator of the numerator. So let's rewrite that as, put it all the way up there, x plus 5 over x plus 1 times x minus 3. And now on the right, well, we probably want a common denominator. So let's write this as 2 over x minus 3, and then multiply both the top and the bottom by x plus 1. So x plus 1 and x plus 1. So now that both the denominators are the same, we can go ahead and combine these two fractions. So x plus 5 minus 2 times x plus 1 all over x plus 1 times x minus 3. So we're at this step. Let's go ahead and factor this numerator. So this is, let's see, x minus 2x is negative x, and 5 minus 2 is positive 3. So negative x plus 3 all over x plus 1 times x minus 3. Looks like if we take a negative 1 out of the numerator, this will become negative x minus 3. And now we have a x minus 3 on both the top and the bottom. So we can cross them out, and we get our final answer, negative 1 over x plus 1. Question 3, the curve y equals 1 over 2x, or 1 minus 2x, all over x cubed minus 1, has one horizontal asymptote, y equals h, and one vertical asymptote, x equals k, and then what is h plus k? So we need to find the equations of the horizontal and vertical asymptotes, and then put them together. So let's start off by finding the horizontal asymptote. Those are just the, like say we have a function that looks like, what's a function that has a horizontal asymptote? I have no idea, but they're obviously horizontal, and there's a pretty easy way to find them based off of the degrees of the numerator and the denominator. So there's three cases. In the case where the degree of the numerator is greater than the degree of the denominator. So in this case, the degree of the numerator is 1, and the degree of the denominator is 3. So this case doesn't apply, but I'll just say it, for completeness. There is no horizontal asymptote. There's none. Now, in the case where it's the opposite, where the degree of the numerator is less than the degree of the denominator, there is 1, it's y equals 0. So that is actually our case. Since 1 is less than 3, we're going to have our horizontal asymptote at y equals 0. So let's put that up here, h equals 0. And then just for completeness, I'll also put the third case where when the degrees are equal, there is one horizontal asymptote. It's y equals c, where c equals the fraction of the coefficients. So in this case, we don't really have to calculate this, but it would be -2 divided by 1, which is -2. So if this was an x cubed up there, then we would have a horizontal asymptote at -2, but we don't. So we have our h equals 0. So now for our vertical asymptote, x equals k, the way we find these is vertical asymptotes are just the values that you cannot plug into the function. So it's kind of like finding our domains is how we find our vertical asymptotes. We ask what values of x can we not plug into our function here. And we can kind of see that since this is a big fraction, we would probably not want to have a dividing by 0 occurrence here. So we can just go ahead and set the denominator, which is x cubed minus 1, equal to 0, and then solve for x. So we can add 1 on both sides to get x cubed equals 1, and then cube root both sides to get x equals 1. So that is our horizontal asymptote, k equals 1. Adding them together, 0 plus 1 gives us 1. Question 4. Consider this big piecewise function. Whenever x is less than 0, it equals -1. Whenever x is greater than 0, it equals +1. And when x equals 0, the function equals 0 as well. So that's that. Which of the following 3 limits exists? So I think this would be helpful. It doesn't seem that hard to just graph out since all of the outputs are constants. So let's go ahead and do that. So let's have some axes and our other axis right there. Whenever x is less than 0, so on the left hand side there, the function equals -1. So going all the way up until -1, the function, or all the way up until x equals 0, the function equals -1. I'm going to put an open circle right there because it is a less than sign and not a less than or equals sign. Now we've got the opposite case on the right side. If x is greater than 0, the function equals +1. So up here we've got that. And then in the middle case, when x is exactly equal to 0, we've got the function equaling 0. So we're going to have a filled in point right there. So that's what this function looks like. Now, which of the following limits exists? So starting with the first one, the limit as x approaches 0 from the right side, does it exist? And yes, it does. So fortunately, this is just a one-sided limit. We would have a problem if this was a just a normal limit. If it was, we had to figure it out if we were approaching from both sides, since they approach different values. The general limit doesn't exist, and that's actually going to be our answer for statement 2. But statement 1 is just asking from the right side, which does exist. So let's circle it. Now statement 2, we just said it doesn't exist because this is the general limit. We have to approach it from both sides, and the limit from the left side does not equal the limit from the right side. So because of that, the limit doesn't exist. And then statement 3 is a bit different. It's the general limit, but of the absolute value of f of x. So if you think about what that's going to do, look down here. Since this is going to be all negative at this point, the absolute value is going to change this from -1 to +1. It's going to cause it to go up here. And now the general limit is all okay. The left-sided limit is going to approach +1 this time instead of -1, which matches up with the right-sided limit. So in this case, statement 3 is valid. And knowing all that, our answer is B. Question 5. The figure shows the graphs of 3 functions. One of them is the position function of a car. Another is the velocity of the car, and the last one is the acceleration of the car. So find which is which. So if I draw a line right here, what you can see is that it kind of has some important points and pieces of information for each one of those functions on that line. So for function A, that is one of its x-intercepts. It crosses the x-axis right at the line. Now function B, it looks like it kind of has a local maximum right at that point. And function C, this one is a little harder to tell, but right at that point, it has an inflection point. You can kind of see on the left, it's concave up, and on the right, it's concave down. So knowing all that, which is which? Well, if we think about function C, it has an inflection point at that point, which means which means that it is, I don't know what I'm saying, which means C is the second derivative of the original function. That's how we find inflection points. We take the second derivative. And since acceleration is the second derivative of position, I'm going to hedge a bet that function C is the acceleration function. So one of these, either B or D. So cross out those three. Now, knowing all of that, we can say the opposite about A. Now, since it crosses the x-axis at this point, it's probably going to be on the opposite end of the extreme. It's going to be the position function. So A is position, which leaves us with D. And just to show that I'm right, B is the one that is right in the middle. It has that critical point right at the line, which means it is the first derivative of the original function. And taking the first derivative of position gives you velocity, which is right there. Question 6, find the limit. So problem with this limit is if we go ahead and plug in the value that x approaches, we'll be left with 4 minus 4 over 0 minus 0, or not 0 minus 0, it'll be 2 minus 2. The denominator here becomes 0, and we can't divide by 0, that's no good. Fortunately, this isn't so bad to figure out because we can just look up here and say, hey, this is a difference of squares. So we can go ahead and factor that out. It becomes x plus 2 and x minus 2, all over x minus 2. Hey, look, we've got an x minus 2 on both the top and the bottom, so we can go ahead and cancel those out. We're just left with the square root of x plus 2. And now when we go ahead and plug in that original value, it won't mess anything up. This will just be square root of 2 plus 2, which is the square root of 4, which equals 2. Question 8, find the limit. So this limit is a special type of limit. It fits the form, or it's pretty close to the form of the limit as x approaches infinity of 1 plus 1 over, actually not 1, let's do k over x to the power of x. This approaches e to the power of k. So this is really close. The only thing is we've got this 4, this extra 4 in the exponent up there. But when I looked online, all you really have to do is multiply that 4 to the k out there. So that's all we have to do. And since our k is 3, that means our answer is going to be e to the 4 times 3, which is 12. Question 9, the half-life of a certain substance is 1,000 years. How much of a sample weighing 100 kilograms remains after 100 years? All right, half-life problem. How we do these is we've got a cool formula for it. So the mass, or I guess quantity of something, equals the initial quantity of that something times 1/2 to the power of t over k. I think maybe in like other half-life problems I've written the k as r, but they're the same thing. Or in this case, a sub 0 is the initial quantity, in this case 100 kilograms. T is the time, in this case it is 100 years, that's how long we're leaving the substance for. And K is the half-life, which is 1,000 years. So that's cool. All the information we're already given is already just formatted on one side of the equation. So this makes it pretty easy for us. So the mass of this is going to be a sub 0, the principal, which is 100 kilograms, times 1/2 to the power of 100 over 1,000. Since we have two different 100s here, it's probably useful if I put some units. That's what your math teachers always told you. Make sure to include your units. So 100 kilograms, 100 years, and another 1,000 years down there. Cool. So let's simplify this. A equals 100 times 1/2 to the power of a tenth. So this is going to be 100 all over 2 to the 10th. And no, not 2 to the 10th, 2 to the 1/10th, which is the same as the 10th root of 2, which is D. Question 10. If f of x equals x squared plus 3x minus 4 all over x squared minus 1, then what is f prime of x? So the derivative of, oh, I just dropped my pen. The derivative of the fraction there. All right, so what we'd probably want to do before just jumping straight into like the quotient rule or something is we can factor both the top and the bottom, both a little differently. The top is going to factor into, let's see, it's going to be two terms here, an x and an x. It's got to be a plus and a minus, and I think it's going to have to be minus 4 plus 1, because 1 times negative 4 is negative 4, and 1 minus 4 is, nope, I switched them up. It's supposed to be plus 4 minus 1. So 4 times negative 1 is still negative 4, and 4 minus 1 is positive 3. So that's how that gets factored. And then the denominator is a difference of squares. So this is going to become x plus 1 times x minus 1. By doing all of that factoring, we now have two terms in both the top and the bottom that can be you can cross out the x minus 1 term. So this now becomes f of x equals x plus 4 over x plus 1. That's a lot easier to take the quotient rule of. So let's go ahead and do the quotient rule now. If we have something in the form of a over b, its derivative equals a prime b minus ab prime all over b squared. So in this case, a is x plus 4 and b is x plus 1. So f prime of x equals a prime, which is the derivative of x plus 4. That's going to be 1. Times b, which is x plus 1, minus a, which is x plus 4, times b prime. That's the derivative of x plus 1, which is 1. This is all over b squared, which is x plus 1 squared. Cool. So simplifying this now, we get, let's see, this will be x plus 1 minus x minus 4 all over x squared plus 2x plus 1. And then the top is going to simplify to 2x minus 3 all over x squared plus 2x plus 1. Our answer, let's see, do we have our answer yet? Oh, no, this isn't 2x. This is nothing because it's an x minus x. So this should just be negative 3 on the top. So yeah, it's just negative 3 on the top, which is E. Question 11. If f of x equals log base 10 of x, then f prime of E equals what? All right, this is testing you over if you remember the derivative of just general logarithms, not just the natural log, which they like to do pretty commonly. So this has a formula. Everything's got a formula. Log base b of a, if you want to take its derivative, that's equal to a prime over a times ln of b. So that's how that goes. Let's fit that to our situation where a is x and b is 10. So this is going to equal, let's see, a prime, that's the derivative of x, which is 1, all over a, which is x, times ln of b, which is 10. And now plugging in e for x, this just becomes 1 over e times ln of 10, which is D. That was quick. Question 12. If f of x equals 1 minus x squared, all times the inverse sine of x, then what is its derivative? So looks like we've got to start with some product rule. We've got two things being multiplied together that we need to take the derivative of. So we know that. derivative of a times b is equal to a prime b plus ab prime. So let's do that. A prime, that's the derivative of 1 minus x squared. That is negative 2x times b, which is the inverse sine of x, plus a, which is 1 minus x squared, times b prime. That is the derivative of inverse sine. I think that is just something you got to remember. It's 1 over the square root of x minus 1. Is it x minus 1 or 1 minus x? Oh, it's 1 minus x squared. Okay, got it. Cool. So it's 1 minus x squared. And that's the derivative. Now we just have to multiply it out, and then that'll be our answer. So on the left, we've got negative 2x times inverse sine of x. And on the right, we've got, let's see, how's this going to go? Well, we can put that in the numerator. So 1 minus x squared all over the derivative, or not derivative, the square root of 1 minus x squared. Is that the final answer? Do we have to do more stuff on top of this? Oh, well, if you kind of think about it, if you divide something by its square root, it's just going to leave you with the square root, since it's the same thing on both the top and the bottom. Because if you do, a squared divided by a, that just equals a. So you do some rearranging and you figure out that, yeah, this is just going to equal what's inside of the square root. So let's go ahead and do that. That was crazy talk. I hope you see what I'm doing. I'm just going to rewrite this as the square root of 1 minus x squared, and then all the stuff on the left. And that should be our answer. It should be B. Question 13. If for differentiable functions f of x and g of x, we've got all of these definitions for a couple different points of f and g, then the derivative of f of g of x at x equals 2 equals what? So, okay, cool. So this is just asking, what is f prime of g of x evaluated at x equals 2? Notice how I still kept that, whatever this is on the right here. You can't just go and plug in 2 for x and then solve it like normal, because think about what we're kind of doing here. We're taking the derivative of something that has an inside function there. And what do we do when we take the derivative of something with an inside function? We do the chain rule. We multiply by the derivative of the inside. So in this case, let's multiply this whole thing by g prime of x. And now that we're in this state, we can go ahead and plug in 2 for all of our x's, and we should get the right derivative. So f prime of, let's see, g of 2, that is 3. So f prime of 3 times g prime of 2, which is negative 1. So f prime of 3 times negative 1. F prime of 3 is 7, times negative 1 is negative 7. Question 14. If cosine of x plus y equals y squared times sine x, then dy over dx equals what? All right, so to differentiate this whole thing, we should probably use implicit differentiation, where we just differentiate like normal, and whenever we take the derivative of something with a y in it, we multiply it by dy over dx. So let's start with that. So the left-hand side, derivative of cosine is negative sine. So this is going to be negative sine of x plus y. Chain rule, got to multiply by the derivative of the inside. So multiply by derivative of x, which is 1, plus the derivative of y, which is also 1, but we just took the derivative with something and a y in it. So we have to multiply that 1 by dy over dx. Awesome. Now moving on to the right-hand side, we've got y squared sine x. That is, we need product rule for that. We need a prime b plus ab prime. So let's do that. A prime is the derivative of y squared, which is 2y times dy over dx, times b, which is sine x, plus a, which is y squared, times b prime, which is derivative of sine, which is cosine x. Awesome. So now we've got a couple dy over dx's here. Let's see if we can simplify this equation to get them all on one side. So let's start by factoring things out and distributing. So sine of x plus y minus minus sine of x plus y dy over dx equals, let's see here, 2y sine x dy over dx plus y squared cosine x. Let's add sine of x plus y times dy over dx to both sides. So let's do negative sine of x plus y equals 2y, 2y sine x dy over dx, let's see, plus sine of x plus y dy over dx. Now let's subtract y squared cosine x from both sides. So this part over here gets canceled. And on the left side, we've got minus y squared cosine x. That's why I left that little gap there. So also we have the terms with the dy over dx in it all on one side. Let's go ahead and take it out. Let's factor it out. So this will be dy over dx equals, or not equals, just times 2y sine x plus sine of x plus y. Cool. And then we still have the same thing on the left. And then at this point, we just divide the two. So let me actually write this out just for completeness sake. Negative sine of x plus y minus y squared cosine x. And now we just divide both sides by 2y sine x plus sine of x plus y. That will give us, I can fit it all here. I got this. dy over dx equals negative sine of x plus y minus y squared cosine x all over 2y sine x plus sine of x plus y. Is that one of our answers? Please tell me it is. This problem was hellish. Yep, it is B. Question 15. Water is poured into a conical paper cup at a rate of 4 cubic centimeters per second. Let's start drawing this out. We've got an upside down cone, the ones they have at, like, I don't know, workplaces and stuff to keep you from loitering. And it has water being poured into it at a rate of 4 cubic centimeters per second. Cool. If the cup is 18 centimeters tall, so 18, and the top has a radius of 6 centimeters, then how fast is the water level rising? So let's do a water level in there when the water is 9 centimeters deep. So at this instant, when the water level is 9 centimeters deep, what is the rate at which it is going up? Oh, and then they give us this complementary volume of a cone function. So I think that's probably going to be the function that we're going to use to deal with this related rates problem, the volume of the cone. So let's just rewrite it. Volume equals pi over 3 r squared h. Now, I don't think this is going to quite work because we have two different variables on the right-hand side here. I think when we go ahead and differentiate this, we're going to have problems, especially with this r here, because the only r we're given is the radius of the entire cone, and that's not really important at all because it's the whole thing, not the radius of, the water level itself. So I think when we try to find dr over dt, that's going to be a problem. So let's try to rewrite that r in terms of h, and then we'll just have one h, one variable on the right-hand side. So how can we do this? Well, if we look at what the original problem says, the big cone is 18 centimeters tall and has a radius of 6 centimeters. And if you also look, this smaller cone that's produced by the height of the water is similar to the big cone, the paper cup. So we can actually use those two pieces of information and make a ratio out of them. So if the big cone is 18 centimeters tall and has a radius of 6 centimeters, then that means the little cone, the water level cone, it has a height of 9 centimeters tall, and x as a radius, and this ratio will have to hold true every single time. So if we do some cross multiplication, we'll get 18x equals 54, and x equals 3. So that is the radius of the little cone, and what that also means is that if you look at the ratios here, this is 18/6 and this is 9/3. It must mean that the radius is always 1/3 of the height. So we can rewrite r as 1/3 of h, so h over 3. And that should work for our related rates problem. So let's rewrite it as pi over, let's see, how can this go? Pi over 27 times h cubed. That way it's a nice and easy power rule. So dv over dt equals, let's see, this will be pi over 9h squared, because h cubed, the power rule of h cubed is 3h squared. Then you just put the 3 with the pi over 27, and then they cancel out to make pi over 9. And this is all times dh over dt. Awesome. So let's see what we're given, what we can plug in for each of these three variables. dv over dt is 4 cubic centimeters per second. That is the rate at which the water volume is increasing. H is the height of the water level, which is 9 centimeters at this instant. And then dh over dt, that's the rate at which the height of the water is increasing, and that's what we're asked to find. So cool, we've got everything covered. Let's plug in these values. So dv over dt is 4 times pi over 9h, which is 9 squared, dh over dt. Solving for dh over dt, we get 4 equals, this will be 9 pi dh over dt. So dh over dt equals 4 over 9 pi. Question 16. I don't know what the heck this is. By linear approximation, the approximate value of the fourth root of 17 is what? So we know how to do linear approximation. F of x is approximately equal to f of a plus f, f prime of a times x minus a. That's how we do linear approximation. First, we have to find out what x, a, f of x, and f prime of x are. Before we do that, though, let's see. Our x is the original value, which is 17. A is a value that is close to x that is far easier to, do this whole thing for. So since the fourth root of 16 is a lot easier to do, it's just 2, let's set our a to be 16, which is pretty close to 17. Now f of x is just the original function, but with an x in place of x. So in this case, it's going to be the fourth root of x. And then f prime of x is the derivative of f of x. So we can rewrite the fourth root of x as x to the 1/4. So that means f prime of x is going to be 1 over 4 times the fourth root of x cubed. That's what that's going to be. So we have all of those. Let's go ahead and do this linear approximation. F of a, that's going to be the fourth root of 16, plus f prime of a, it's going to be 1 over 4 times the fourth root of 16, all cubed, times 17 minus 16. So simplifying this, we get fourth root of 16 is 2, plus 1 over 4 times, the fourth root of 16 is also 2, 2 cubed is 8, times 17 minus 16 is 1. Awesome. This is all 2 plus 1 over 32, which equals 65ths, 30 seconds. All right, that's E. Cool. Question 17. The intervals on which the function f of x equals x to the fourth minus 4x cubed plus 4x squared is decreasing, and those on which it is increasing are given by what? Cool, just a vanilla increasing and decreasing problem. This is critical points 101. How we find those is we first find the first derivative of f of x, set it equal to 0, and then solve for x. So f of x's first derivative is 4x cubed minus 12x squared plus 8x. setting that equal to 0, let's see, we can divide by 4 for everything. So 0 equals x cubed minus 3x squared plus 2x. Now we can take an x from everything on the right side. So 0 equals x times x squared minus 3x plus 2. Splitting this off into two separate equations, we get x equals 0 and x squared minus 3x plus 2 equals 0. Left-hand side is already solved. That is one of our critical points. And on the right-hand side, we can factor this as, I think this is going to go x minus 1 plus 2 because, oh, no, that won't work because the 2 is positive. We make this a negative. That'll work. There we go. Because negative 1 minus 2 is negative 3, and negative 1 times negative 2 is positive 2. So cool, that worked out. We have our other two critical points at x equals 1 and x equals 2. So these are our three critical points. Looks like we can automatically rule out B because it involves a critical point of 3, which never comes up. So we know that that one won't be real and won't be true. It's not an answer choice. And now figuring out the ones that are, let's see, we can do x, and since we're doing critical points, let's make our output be f prime of x. And then plugging everything in, as well as a few intermediary points. Let's see, we've got 0, 1, and 2, as well as, let's maybe do negative 1, a half, 3 halves, and 3. We already have 3 of these points, as we've defined here. 0, 1, and 2 will all yield 0. And then for the other 4, we're just concerned with its signage, so whether it's positive or negative at the end of it. So we can take a couple shortcuts, which is fun. So doing negative 1, so let's do f prime of negative 1. First off, let's actually rewrite what f prime is all the way up here. This is equal to x times x squared minus 3x plus 2. Well, technically it's 4x, but since we're just dealing with the sign, that constant isn't going to change what the sign is at all, so we can just forget about it. Now, doing all of this, we get f prime of negative 1 equals, let's see, this is going to be negative times, let's see, this inside is going to be 1 plus 3 plus 2, which is positive, so this is going to end up being negative. So f prime of negative 1 is negative. Now, f prime of a half equals, let's see, on the outside it's going to be positive. On the inside it's going to be a fourth minus 3 halves plus 2. That's too much to do all in my brain. This is going to be a fourth minus 3 halves plus 2, which is, let's see, a fourth minus 3 halves. Ugh, this is nasty. Well, 3 halves minus a fourth is 5 fourths. So this is going to be negative 5 fourths plus 2, which is positive. So f prime of a half is positive. Now f prime of 3 halves, that's going to be 9 fourths minus 9 halves plus 2. Let's see, that's going to be 9 halves minus 9 fourths is 9 fourths. So this is going to be negative 9 fourths plus 2, which is negative 1 fourth. So that's negative right there. And then finally, f prime of 3 is going to be 9 minus 9 plus 2, which is just positive 2. So this is positive. Great. This is just a very standard, easy-going graph where none of these critical points ended up being fake critical points, which is cool. Now we just have to determine each of these critical points, are they minimums or maximums. So we look at the surrounding points there. So in the case of critical point 0, on the left it's negative and on the right it's positive. So that means in terms of f of x, like graphically, it's going to look like this, where we have x equals 0 in the middle. On the left is a decreasing slope, and on the right is an increasing slope. That's what the minus and positive mean. So in this case, it's a minimum, so everything on the left is going to be decreasing. So that is the interval from negative infinity to 0. We already ruled out B, so that also rules out A because it says it increases from negative infinity to 0. Now, going for the other ones, well, we can already say that the same thing about critical point. Whoops, I circled the wrong thing. We can say the same thing about critical point 2 because it is decreasing on the left and increasing on the right. So it's also decreasing on the interval from 1 to 2. So that is what C says right here. It's decreasing on negative infinity to 0 and 1 to 2. Now for the increasing intervals, it's increasing from 0 to 1 and 2 to infinity, which is also exactly what C says. 0 to 1 and 2 to infinity. I'm going to bet that C is right, that the others are wrong. That is awesome. Question 18. The minimum value of the function f of x is what? So there's an easy way to do this. We just find all of the local minima of f of x and then plug each of them back into f of x and then just choose the one that's the smallest, and then that'll be our absolute minimum. So finding local minima, that's a critical point question. So we set f prime of x equal to 0 and then solve for x. So 0 equals, let's see, this is going to be 3 halves x cubed plus 3x squared. And then solving for x, let's see, we can take x squared out of everything. So 0 equals x squared times 3 halves x plus 3. Fractioning this off into two separate equations, we get x squared equals 0 and 3 halves x plus 3 equals 0. On the left side, we've got x equals 0. Take the square root of both sides. That is one of our critical points. And on the right side, we've got, let's see, subtract 3 on both sides. 3 halves x equals negative 3. Multiply both sides by 2/3. We get x equals negative 2. So cool, we've got our two critical points. That makes it easy on us because we only have two values to plug in. So let's do that. F of 0 equals 0 because everything here has an x in it, so no matter what, this is going to equal 0. And then f of negative 2 is going to be, let's see, 3/8 times 16. That's a big number. It's going to be 6. I think because 16 divided by 8 is 2, and 3 times 2 is 6. And then negative 2 cubed is negative 8, so that's going to be minus 8, which equals negative 2. And since negative 2 is smaller than 0, that means negative 2 is the minimum value, so C. Question 19. A box with a square base and an open top must have a volume of 40 cubic inches. What are the dimensions of the box that minimize the amount of material to build it? All right, let's draw this out. We have a box with an open top and a square base. So let's make this base length B and a height of h. This is open at the top, and we have to figure out the minimum amount of material that will make the volume equal 40 cubic inches. Now, there's a really quick way to do these open top related rates problems. The base lengths will always be 2 times what the height is. So base equals 2h every single time for these box problems. So if you just look through answer choices A through E, there's only one choice that fits that. It's D, because the height is cubed root of 10, and each base length is 2 times the cubed root of 10. So that's the answer. We're already done. Question 20, find an antiderivative of the function f of x equals x minus 1 squared all over x. So, all right, this is just a basic antiderivative integral question. These are the opposite of derivatives, so imagine if this was some function's derivative, what is the original function? So how we can, I think we can solve this one, is let's first expand out this top term here, x minus 1 squared. So that'll become x squared minus 2x plus 1 all over x. and then we can go ahead and split this into three separate fractions, which are x squared over x minus 2x over x plus 1 over x. And then a couple of these will simplify, so this will become x, this will become 2, this will become 1 over x. Now we can go ahead and find the antiderivative of each of these one terms, because that's how integrals work. If you have added or subtracted terms, you can go ahead and find the integral of each term separately. So let's do each of these. Let's start off with this x one. So imagine if this was some function's derivative, what would its original function be? In this case, it would have to be 1/2 x squared, because in this case, if you take the 2, move it out front, and reduce it by 1, you get x. So that's how you get that. Second term here, the -2. So typically, when you have a constant and you take its derivative, it just zeroes out. It becomes a 0. But we need to go the other way around. We need to increase its degree by 1. So this 2 is going to become 2x, because this x has a power of 1. When you move it out front, it becomes -2 times x to the 0th power. And then this 1 over x, well, we know that the derivative of ln of x is equal to 1 over x, and we're going the opposite way around, so the integral of 1 over x is ln of x. And that is the answer. Question 21, a Riemann sum question. We're asked to find the left Riemann sum using three rectangles of the function sine of x from x equals 0 to x equals 1/2, or pi over 2. So the function sine of x isn't too complicated, so I think we can actually try to graph this out and see what's going on visually. So if we have our axes here, and our two endpoints are 0 and pi over 2, then our function sine of x, well, sine of 0 is 0, and sine of pi over 2 is 1. So that's going to be the two endpoints there, and I think between those it's just kind of interpolated like this, where afterwards it goes down. And we are asked to find the left Riemann sum, so when we're plotting out these points for the heights of these rectangles, we need to be using the left side of those rectangles. So we need to start out on the left side, and it looks like there's going to be three boxes, so it's going to be something like this. We have three rectangles, and they're going to go up like this, where we have those endpoints right there, and then they go right like that. So that is how we draw all of these boxes. Well, first off, one of these boxes has an area of 0, so we don't have to worry about that. The other two, we just find their areas, add them up, and then that'll be our estimated area under the curve. So how we do this is first off, we have a width of each box, and then times the approximated height of each box. The width of each box, in this case, since it's pi over 2 units long, and we have three rectangles, that means the width of each rectangle is pi over 6. And then we just have to add the height of each box. So the height of the first box is 0. Height of the second box is, let's see, this value here is pi over 6. So this is going to be f of pi over 6. That is 1/2. So sine of pi over 6 is 1/2. And then we have the height of the third box. So that's going to be f of pi over 4. Wait, is that? Hang on, I don't know if that's 100% right. Okay, a third of pi over 2 is pi over 6, right? Am I wrong in that statement? I don't think I am. And then what? Okay, it's late at night. I don't know what I'm thinking. A third of pi over 2 is pi over 6, and 2/3 of pi over 2 is pi over 3. Okay, and then we have sine of pi over 3 for the height of the third box, which is √3 over 3. Okay, now I got it. So, nope, not √3 over √3, it's √3 over 2. There we go. So that is the estimated area under the curve. We can rewrite this a little bit by taking out 1/2 from each of the terms in the middle. That will bring it to the outside and make it equal to pi over 1 plus √3 all over, this will be 6 times 2, which is 12, which is answer choice C. Question 22. If a particle is moving at the speed v of t equals 1 over t squared plus 1, then the distance it covers from time t equals 1 to t equals 3 is what? So this is an integrals question, an antiderivatives question. We are given the velocity of some function, and we need to find its distance function. That's the opposite of what you're usually asked in this class, where you're given the distance function, and you're asked to find the velocity function. So we're doing an antiderivative here, and what you might notice is the form of the function of v of t here, 1 over t squared plus 1. You might remember that the derivative of inverse tangent is equal to 1 over x squared plus 1. So you might be able to draw the conclusion that, hey, we're doing an antiderivative here, and we're given this. So the antiderivative of this is going to equal inverse tangent. And that's exactly right. So we can go ahead and skip a bunch of integration techniques and just get right into what the integral is, which is inverse tangent of t. So now all we have to do is evaluate this from 1 to root 3. So we just do inverse tangent of root 3 minus the inverse tangent of 1. So doing this, inverse tangent of root 3 is unit circle stuff. That is pi over 3. And inverse tangent of 1 is pi over 4. You can either use that big table of unit circle values or just kind of remember what they are. And this is equal to pi over 12, which is our answer. Question 23, suppose that g of x equals the integral from 4 to x squared of e to the t squared dt. Find g prime of 2. So for this problem, instead of evaluating exactly what this integral equals, we can realize that, okay, we're taking an integral, and then we're going to take the derivative of it. And those two cancel out. The opposite of derivatives is integrals, and the opposite of integrals is derivatives. So we can just kind of skip all of that and go ahead and plug in x squared into t. And that will almost get us all the way there. I'm going to start us off with that. So that's going to be e to the x squared squared. That works, but what we also have to do is if the term in the top part there, if it's not just an x, you have to basically do a chain rule. You have to multiply this by its derivative. So we're going to multiply this by the derivative of x squared. So that should be our answer. That should be what g prime of x equals. So let's go ahead and find out what that is. So this is going to be e to the x to the 4th times 2x. So that's what that's going to be. Now, okay, if this is all g of x or g prime of x, then g prime of 2 equals, this is going to be e to the 2 to the 4th times 2 times 2. This is equal to 4. 4 times e to the 2 to the 4th is 16, which is A. Question 24. Evaluate the indefinite integral of sine hx plus sine h cubed of x. And they also give us a little hint of that cosine h squared plus minus sine h squared equals 1. So we're probably going to use that at some point. I think how we can start solving this integral is by first taking out a sine h from both of these terms. That will give us, let's see here, the integral from sine hx times 1 plus cosine h squared, all is dx. And now, if we look back at the left here, cosine h squared minus sine h squared equals 1, we can rewrite this as cosine h squared. We can just subtract or add a sine h squared to both sides. So cosine h squared equals 1 plus sine h squared. And you'll notice here, that's exactly what we have. Oh, I wrote a cosine here instead of a sine. I don't know why I did that. That's supposed to be a sine. Now you notice on the right here, now it's this exact form. The right-hand side of this equation is what we have in the function here. So we can go ahead and replace that with cosine h squared. So this is going to be sine hx times cosine. I keep hitting this fucking button on the side of my pen. It's annoying. Cosine h squared x dx. Now what we can do here is I believe a little u substitution would be useful. So we can go ahead and select our u. I think a good one would be cosine h. So we could do u equals cosine h. Then taking its derivative gives us du equals derivative of cosine h is sine h. and then it's dx. It's very important that for the u substitution you don't forget the dx there, because what we're going to do next is solve for it. So we're basically going to divide both sides by sine h. So dx equals du over sine h x. So now when we go ahead and substitute everything we know, we get sine hx times, so we said cosine h is equal to u, so this is now u squared. And this is all times dx, but we said that dx equals du over sine h. So that's how we solve that. You'll see that the sine h's will cancel. We're just left with u squared du. And this is infinitely easier to take the integral of. So let's go ahead and do that. We kind of go the other way around with the power rule. First, we increase the exponent. So this is u cubed, and then divide all of this by it. So u cubed all over 3. So that is the indefinite integral, and we just plug in u with, in this case, cosine h. So we go ahead and do that. We get cosine h cubed all over 3. Why is that? Oh, that is the right answer. So A, I forgot the plus C, and B, I'm blind. The answer is C. Question 25. You've made it. We have an integral from 0 to pi of sine of t times the square root of 1 plus cosine of t. So I think we can instantly start off with some u substitution. I think good things will happen if we set our u equal to 1 plus cosine of t. Usually your u has a bunch of added stuff on top of it. Like in this case, we have this square root on the outside. So I think our good choice for u will be the thing that's on the inside. So u equals 1 plus cosine of t. Taking its derivative, we get du equals, this is going to be negative sine of t, dt, and then solving for dt, we get negative sine, we get du over negative sine of t. So plugging in everything that we know, we get the integral from 0 to pi of sine t times the square root of, we said 1 plus cosine of t is equal to u. This is times du all over negative sine of t. So the sine t's are going to cancel, and we're left with integral from 0 to pi of square root of u du, all times this negative sign. We can actually just throw that out front since it's technically a constant. You can just put them out front. And that is a much easier integral to take, especially if you write this as u to the 1/2 power. We do some opposite power rule here. So this integral here, what we do is we increase it by 1 and then divide it by that. So if we increase this by 1, this will be u to the 3/2, and then we divide this by 3/2. This is going to be 2/3. So that is the integral now. Normally you have a plus c here, but this is a definite integral, one where you have endpoints, so we don't really need a plus c. And now we go ahead and substitute that u with what we said u was, which is 1 plus cosine of t. So this is negative 2 times 1 plus cosine of t to the 3/2 power. And we can replace this 3/2 power with what it really means, which is the square root of 1 plus cosine t cubed all over 3. So now we just have to evaluate this from 0 to pi. So what this means is we plug in pi and then subtract it, plug in 0. So this is negative 2 times, what did we say this was? The square root of 1 plus cosine of pi cubed all over 3 minus a negative of 2, all of that square root, 1 plus cosine of 0 cubed all over 3. Now let's simplify. So on the left here, this is going to simplify down to 0 because this inside part, cosine of pi is negative 1, and 1 minus 1 is 0. So that's going to make this entire numerator 0, which makes all of this 0. So it's 0 minus a negative. These negatives are going to cancel each other out. We're just left with whatever this is. So it's going to be 2 plus, let's see here. Cosine of 0 is 1. 1 plus 1 is 2. 2 cubed is 8. And the square root of 8 is 2 root 2. So 2 times 2 root 2 is 4 root 2 all over 3. And that is our answer.